Okay, hello everyone. Okay, so over here we will be going through some of your homework questions. Okay, for trigonometric ratios of acute angles. Specifically for this part, we are just looking at finding lengths. Okay, what do I mean by finding lengths? Okay, previously in chapter 8 on Pythagoras theorem, we learned about how three sides, okay, can be related to each other using Pythagoras theorem for a right angle triangle. Okay, so if I know two of the sides, I can find the length of the third side. Okay, in the concept of trigonometric ratios, we learn about how an angle, okay, can be related to two other sides in a right angle triangle. So if you know two of the sides, you can find the angle, or you know an angle and one side, you can find the other side. Okay, so basically that's the main gist of this this chapter. Okay, linking one angle and two sides together. And of course, a triangle, there's three different sides. So how do we know which two sides? That will bring us to the three different trigonometric ratio: your sine, cosine, and tangent. Okay, so in this first part, okay, we will just be looking at questions that are asking you to find the one of the sides, okay, given that you know one of the angle and the other side. So one of the important thing that you should be able to do is to determine, okay, which trigonometric ratio to use. Okay, so without further ado, okay, we'll be going through six questions. Okay, 3 from exercise 9.1, 3 from exercise 9.2. Okay, the ones from 9.1, we are looking at question 1, 2, and 6. These are the very basic questions, okay, to warm you up and make sure that you know what you're doing. And in exercise 9.2, we'll be going through questions 7, 11, and 13. Those are the more typical exam style questions, okay, where you really need to be able to figure out, okay, which is your right angle triangle, which are the sides that are involved, and apply accordingly. Okay, without further ado, let's begin. So we start off with question 1. So question 1, okay, is just trying to see whether you understand for the three trigonometric ratios, which are the two sides that are linked to it. Okay, so over here, let's look at the first question. State the values of sine theta, cosine theta, and tangent theta in each of the following right angle triangle. So over here, I have triangle ABC, okay, with right angle at B. Okay, the reference angle I'm looking at is theta, which is at C over here. Okay, so first thing you need to know is the three different sides to a right angle triangle. Okay, first will of course be your hypotenuse, which you already learned when looking at Pythagoras theorem. It is the longest side, okay, in a right angle triangle, the side that's opposite the right angle. Okay, next we have the adjacent and the opposite side. This will depend on which angle is your angle of interest or the angle of reference that you're looking at. In this case, we are looking at this particular angle here, theta. So in this case, if this is my angle of interest, the angle that we are looking at, then the opposite will be AB. And if AB is the opposite, then BC will be the adjacent. Okay, the word adjacent means beside, okay, side by side. Okay, so this is the angle, this is the side that is adjacent to the angle. It's just beside the angle. Okay, so knowing that, we also need to bring out our concepts of the sine, cosine, tangent, okay, with the very common phrase, we call it tua kaso. Okay, so where, okay, let me do some writing. So in tua kaso, okay, so basically what this means is that the tangent, okay, the function of tangent, okay, will link OA, means the numerator will be A, which is opposite, okay, and the denominator will be A, sorry, the numerator is O, which is opposite, and the denominator will be A, which is adjacent. Okay, so this is the relationship linking the angle and the two sides together. Okay, then we also have your cosine with AH, so it's adjacent over hypotenuse. So adjacent over hypotenuse, and then of course so. Okay, so sine theta equals to opposite over hypotenuse. Okay, so with this, we are able to solve these questions, okay, just to do the basics. So if I want sine theta, So this is my theta. Sine is opposite over hypotenuse. Opposite is AB, hypotenuse is AC, so it will be 5 over 13. Okay, so for the first one, your sine theta will just be 5 over 13. Cosine theta is adjacent over hypotenuse. Adjacent is 12. Hypotenuse is 13. So this will be 12 over 13. And the last one is opposite over adjacent. So opposite is 5. Adjacent is 12. So tangent theta is 5 over 12. Okay, so let's check our answers together. Okay, so 5 over 13, 12 over 13, and 5 over 12. Okay, which is pretty straightforward. Okay, yeah. Next, okay, for this particular right angle triangle, we have DEF. Okay, you can see that the hypotenuse will be EF. This is the longer side of 29. Is also the side that's opposite the right angle. Okay, the angle of interest we're looking at is at F. Okay, theta is here. So in this case, DE will be the opposite. DF will be the adjacent. Okay, because DE is opposite of this angle. Okay, so with that, let's look at the same thing. So sine theta, sine will be so SOH, sine, opposite over hypotenuse. Opposite is 20, hypotenuse is 29. So the first one, sine theta, will be 20 over 29. Next, cosine theta is car, so it will be AH. So CAH, AH is adjacent over hypotenuse. Adjacent is 21, hypotenuse is 29, so it will just be 21 over 29. Last but not least, tangent is TOA. TOA is TOA, so opposite over adjacent. My opposite is 20, my adjacent is 21, so it will be 20 over 21. Okay, this part should be quite simple. Okay, this is just to warm up, to let you refresh, what are the different sides. Okay, then we move to question 2. Question 2 is to just get you to practice pressing calculator. Do you know how to key all this into your calculator? So it's pretty quite simple. So sine 80 degrees, make sure that your calculator is in a correct mode. Okay, it should be in degrees mode, so meaning at a calculator you should see a small little D, okay, written over there. If you see a letter R, means you're in radian mode, then something is wrong. Okay, do change it back to degree modes. Okay, so over here is all in degrees. Okay, so use a calculator to evaluate each of the following. Give your answers corrected to 4 significant figures. So all you need to do is just key into a calculator. I'll just show you the answer. Sine 80, okay, you should get 0.9848. Cosine 36, okay, you should get 0.8090. Tangent 37, you should get 0.7536. Okay, so these are the most basic. You just need to key in. Okay, you should be able to get an answer. Next, we have D, 4 sine 20 degrees. So you take 4 times sine 20. Key to your calculator, you should get 1.368. Okay. Part E, you have cosine 9.8 degrees plus 6 times cosine 34 degrees. Same thing, key into a calculator, you should get 5.960. Then F, you have 2 tangent 18.7 plus 5 tangent 87.6. Key into a calculator, you should get 120.0. Okay, then G, you have 2 sine 85 plus 3 cosine 17. So 2 sine 85 plus 3 cosine 17, key to a calculator, 4.861. And the last one, you have 4 tangent 50.1 minus 3 sine 29.6. You should get 3.302. Okay, so this should be pretty straightforward. Okay, just to get you to just know how to press the calculator. Okay, next, okay, we move on to a practice question. So far we have just been warming up, revising whether you know what are your trigonometric ratios, your Tuakaso, okay, and how to key in a calculator. Next, we start to apply. Okay, so question 6 over here gets you to, I give you one angle on one side, I ask you to find the other side. Okay, so over here, let's start with the first question. I have triangle ABC. Okay, it's a right angle triangle. Okay, the reference angle here is 32 degrees at A. Hypotenuse is given, which is 20. Ask you to find X and ask you to find Y. So you are looking at X. So just a quick recap. Trigo links two sides and one angle. So in this case, this is the angle. The two sides, AB is one of the side definitely, because we need to find this. The other side, we'll use a known side. In this case, I know what is AC, so I'll use this side. So I'm linking these two sides with this angle. So this is the angle and these are the two sides. This is the hypotenuse. This is the adjacent. So the Trigo ratio that links the adjacent and hypotenuse will be cosine. So with that, you know that, oh, I need to use cosine. And you know that cosine is equals to adjacent over hypotenuse. So cosine 32 degrees is equals to adjacent, which is AB, which is X, over the hypotenuse, which is AC, that is 20. Okay, so let's take a look at the answer. Oh, this one, okay. So cosine 32 equals to X over 20. Then all you need to do is to find X. So in this case, I'll multiply both sides by 20. So over here, 20 will disappear. X will just be equals to 20 times cosine 32. Okay, you should get 17.0. Okay, cm. Okay, correct to 3SF. Okay, just now I think I didn't mention, okay, about rounding off. When you're doing any form of rounding off, okay, the previous number, you look at it, if it is less than 5, okay, meaning if you see 0, 1, 2, 3, 4, you round down. Okay, if the previous number, the next number you see 5 or more, so meaning you see 5, 6, 7, 8, 9, then you will round up. Okay, so please take note when you're doing the rounding off. So that is for X. How do you find Y? So if this is the reference angle, Y will be considered opposite. Okay, so two sides, one angle. This is my angle. This is the side that I want to find. A known side I have is AC, okay, which is 20. So I have opposite and hypotenuse. So to link my opposite and hypotenuse, okay, so I will use so. So, okay, means sine equals to opposite over hypotenuse. So sine 36 will be equals to opposite, which is BC, which is Y, over hypotenuse, which is AC, 20. So sine 32 equals to Y over 20. Okay, so that's what you have over here. Same thing, multiply both sides by 20. I get Y equals to 20 sine 32. Key into calculator, you should get 10.6. Okay, so you can see how just now question 1 and question 2 build you towards this. Question 1 teaches you how to set this up. Do you know which sine, cosine, or tangent, which are the two sides that is involved? Question 2 get you to know how to key this in the calculator to solve. Okay. Next, we move to part B. So part B over here, okay, I have triangle DEF. Okay, right angle at D. Given angle is at E, 59 degrees. Okay, given side is DF, okay, which is 7. So if this is the reference angle, the angle of interest we are looking at, this given side will be considered opposite. Okay, this is opposite of 59 degrees. So we start with finding X first. So X is directly opposite. A right angle is also the longest side. So X is my hypotenuse. So one angle's two sides, 59 degrees is the angle. The two sides, one will definitely be X. The other one is the known side that I have over here, DF, which is 7. Okay, so we are linking opposite and hypotenuse together. We will be using sine. Okay, so sine equals to opposite over hypotenuse. So sine 59 degrees will be equals to 7 over X. Okay. So sine 59 degrees equals to 7 over X. So take note, previously my X was on top. All I need to do is just multiply both sides by 20. Okay, I'll get X equals to 20 cosine 32. Okay, but over here my X is in the denominator. So you can do some cross multiplication. X will be equals to 7 over sine 59. Okay. So this one is your basic algebra that you have learned in Sec 1. How do you manipulate your algebraic equations when there's a bit of fractions around? Okay, so now you know that X equals to 7 divided by sine 59 degrees. Key into a calculator. Okay, you should get 8.17. Okay. Okay, once you have 8.17, next, okay, we try to find Y. So Y is adjacent to this angle, 59 degrees. So I have adjacent, I have opposite. Okay, so we will be using tangent. Okay, because tangent is opposite over adjacent. So tangent 59 degrees is 7 over Y. Okay, so let's take a look. Tangent 59 degrees is 7 over Y. So Y will be equals to 7 over tangent 59 degrees. Okay, key into a calculator, you should get 4.21. Okay, I think one thing that's missing over here is all of them, I think the units are missing, correct? Okay, over here they say that the units of length over here is all in cms. Okay, so over here actually you should write cm. Like here is 10.6 cm, here is 8.17 cm, here is 4.21 cm. Okay, we move to part C. Okay, part C, another right angle triangle, triangle ABC. Okay, so the reference angle here is my 63.2 degrees. I need to find X. So BC is my adjacent. This is the given side. X is my hypotenuse. So which is the trigo ratio that links adjacent and hypotenuse? Okay, you have car. Okay, to a car, so car adjacent and hypotenuse, so you use cosine. So cosine 63.2 will be adjacent over hypotenuse, so cosine 63.2 will be equals to 48 over x. Okay, so let's take a look. Cosine 63.2 is 48 over x, so x will just be equals to 48 over cosine 63.2. Key into a calculator, you should get 106, okay, when corrected to 3SF. So take note of the cm also. Okay, so once you have x, next is to find y. So this is y. Okay, so y is considered opposite to this angle. So I have opposite, I have adjacent. So this one will be using tua, so it will be tua, okay, your tangent. Okay, because tangent is equals to opposite over adjacent. Okay, so tangent 63.2 will be equals to y over 48. Okay, so let's take a look at the answer. So tangent 63.2 equals to y over 48. So y will just be simply equals to 48 times tangent 63.2. Okay, I multiply both sides by 48. So this side, the 48 disappears. This side will get a 48. Okay, then you key into a calculator, you get 95.0. So usually we'll write the number in front of the trigo ratio so that we don't mix up with the angles. Okay, so but basically it just means that this is 48 times tangent 63.2. Okay, last but not least, part D. Okay, this is part D. I have triangle DEF. This is my angle. Okay, I'm looking at X. So which is the trigo ratio I should use? So based on this angle, X is considered adjacent. The known side is my hypotenuse. So adjacent and hypotenuse to a car, so there will be car. So cosine 38.7 will be equals to X over 29.2. Okay, because adjacent over hypotenuse. So cosine 38.7 equals to X over 29.2. So X will just be simply 29.2 times cosine 38.7. Key into your calculator, you should get 22.8. Okay, corrected 3SF. Make sure you have your units of cm. Lastly, to find y, based on this angle, y is considered an opposite. So you have opposite, you have hypotenuse. So to a so you will use so, okay, because opposite and hypotenuse, so you use sine. So sine 38.7 will be equals to y over 29.2, okay, because opposite over hypotenuse. Okay, so by now you should know how to apply all this. Okay, so if you are still not sure, okay, do look through what I just explained just now. Okay, otherwise you can come and find me, okay, so I can explain to you. So y will just be 29.2 times sine 38.7 degrees. You should get 18.3 cm. Okay. So that's question 6. So these are the very basic questions, okay, to see whether you can apply your trigonometric ratio, okay, using Tuakaso. Okay, next we go to the more typical exam style questions, okay, where there's some story to it, okay, to get you to apply. We start with exercise 9.2, question 7. So in the diagram, A and B are two different levels on a vertical building ABC. So vertical building means this is a straight line. The point D is 50 meters away from the foot of C. Okay, we know that this is a right angle because all buildings are supposed to be perpendicular to the ground. Okay, then they tell the angle CAD is this angle is 47 degrees. BDC is 27 degrees. Ask you to find the distance AD. Okay, so every time, remember, we are now looking at trigo is one angle to two sides. Okay, so if AD is one of the sides that I want to know, this AD is part of the triangle ACD. So it's this triangle. I know this side. This side is what I want to find. I know this side. So these are the two sides that can link together. Which angle do I know? I know this angle 47 degrees. So I'm using this angle and these two sides. Okay, so that's always the first thing you do. You need to look at which are the angle and the sides that you're looking at. Once you identified them, then you can see which trigo ratio to use. So this is the angle, this is hypotenuse, okay, this is opposite, okay, this angle, this is opposite. So opposite and hypotenuse, I'll be using so I'll use so, because sine theta equals to opposite over hypotenuse. So sine 47 degrees will be equals to 50 over AD, okay. So after that, everything is just the same. AD will just be 50 over sine 47. Key into a calculator, get 68.37. Or actually, for maths, we round off to 3SF, 68.4. Okay, once you know AD, next they ask you to find the distance AB. So AB is this distance. It's not exactly part of any right angled triangle. So in class, I did mention before, okay, if they are asking you to find a length that's not, you can't find it directly. Okay, usually there's two strategies. If it is a longer length, it could be the sum of two shorter parts. So you find a shorter part, you find a shorter part, add them together. That could be the answer. Or if it's a shorter part, then likely you need to find the longer minus another side. So in this case, this is a shorter part, AB. I want to find AB, I'll need to find what is AC minus away, BC. Okay, so the steps might not be so straightforward. So first to find AC. So AC is this triangle, ACD is the big triangle. I know this side. Okay, I want to find this side. So based on the angle 47, this is opposite, this is adjacent. If I'm linking opposite and adjacent, there will be tangent. Okay, cause TOA. So tangent 47 degrees will be equals to 50 over AC. Okay, so that's the first step. Tangent 27 is, tangent, okay, sorry, they are looking at BDC first. Okay, I think we are looking at ADC first. So sorry, tangent 47 is 50 over AC. Okay, so that's what I'm talking about. Okay, so AC will just be simply 50 over tangent 47. You know that AC is about 46.63. Okay, they use a bit more decimals first. Okay, because that's not the final answer. Final answer is 3SF. Okay, but I think subsequently upper sec teacher usually teach you your intermediate you want to use, you use 5SF instead of 4. Okay, so that is more accurate. I found what is AC. Next I need to find BC. So I'm looking at triangle BCD. So BCD, I know this is angle 27. This is what I'm trying to find. And the unknown side is here is still 50. Okay, so in this case, this is the angle, this will be opposite, this will be adjacent. So same thing, I'll be using tangent. So tangent 27 degrees will be equals to BC over 50, which is what we have here. Tangent 27 is BC over 50. BC will just be 50 times tangent 27. Key into a calculator, get 25.48. Then to find what is your AB, all you need to do is just take AC minus away BC. Okay, because over here, to find AB, you take AC, the long one, minus BC, the shorter one, okay? So you take 46.63 minus 25.48. It will be best if in your calculator you can key in the full thing. So instead of taking 46.63 minus 25.48, you key in 50 over tangent 47 degrees minus 50 times tangent 27 degrees. Okay, then your answer should be 21.2 meters. Okay, corrected to 3SF. Final answer must be in 3SF. Intermediate, if you do 5SF or what, it is okay. Okay, so that is question 7. Okay, next we move on to the last two questions, question 11 and question 13. So question 11 over here, I have a tower AB directly opposite the building of CD. Okay, they tell you that the height of CD is 30 meters. They tell the angle CBD is 29 degrees, angle BAC is 57 degrees. Ask you to find the distance BC. So BC over here. So we are looking at this triangle BCD. I know CD is 30. Okay, I want to find BC. My reference angle is 29 degrees. So one angle's two sides. So 29 with 30 and BC is what I'm trying to find. So what are these sides? Based on this angle, this is the opposite. Okay, this is the hypotenuse, so it's opposite and hypotenuse. We use the trigo ratio of sine. Okay, so sine 29 degrees will be equals to 30 over BC. Okay, so sine 29 degrees equals to 30 over BC. Okay, so to find BC will just be 30 over sine 29. Key into a calculator, you get that BC is about 61.88. Okay, but 3SF, so 61.9. Okay, next we move to part B, the horizontal distance between the tower and the building. So horizontal distance, basically you're looking at finding BD. So to find BD, same thing, I can look at triangle BCD. I know this is 30, I want to find this. So in that case, this angle will link this adjacent side with the opposite side together. So adjacent opposite will be using tangent. So tangent 29 degrees will be equals to opposite over adjacent, so 30 over BD. Okay. So tangent 29 degree will be 30 over BD. Okay, so BD will just be 30 over tangent 29. You find that BD is round to 3SF 54.1. So the horizontal distance between the tower and the building is 54.1 meters. Okay, once you find this distance, okay, next part of the question, they ask you to find the height of the tower. Basically, they're trying to ask you to find this. So in this, then you realize that, hey, this is not a right angle triangle. How do I make use of this? The very typical trick, okay, is to create your own right angle triangle. So you can draw a dotted line from C across to this side, make sure that it's perpendicular. So with that, if you know CD is 30, you know that this side will also be 30. Then all you need to do is to just find this other part, okay, add these two together, okay, then you can find the height of the tower. So based on what you draw over here, let's call this E. Okay, we call this E, this is 30, this must also be 30. So key thing is I need to find out what is AE. Okay, then I plus 30, that will be my answer, okay, of the height of AB. So how do I find AE? Okay, you look at some of the angles over here. Okay, how do they get 29 and 33? You know that this is 29 degrees using alternate angles, okay, because the horizontal will be parallel to the BD. This is 29, this must also be 29. How do I know that this is 33? Let's take a look. So if this is 57 degrees, okay, then this is a right angle triangle. So AEC is a right angle triangle. This is 90, this is 57, this will be 180 minus 90 minus 57. I get 33 degrees. Okay, so this is how I do my setting up. Okay, but key thing is I know this is 30, I want to find what is AE. Okay, so I know this is 33 degrees. Okay, I want to find AE. I need another side, either AC or EC. So which are the sides that I know? If over here I don't know what is AC, but do I know what is EC? Yes, actually EC is the same as BD, which I have found the horizontal distance between the tower and the building. So if I know this horizontal distance, I want to find this. Based on the angle of 33 degrees over here, I can make use that this is opposite, this is adjacent. Otherwise, I can also make use of 57 degrees here. This will be adjacent, this will be opposite. Okay, the answer should be the same. Okay. So in this case, they make use of 33 degrees, meaning they use this angle 33. So tangent 33 will be opposite over adjacent. Opposite is what I'm trying to find. AE. Then this will be equals to BD, which is 54.1. Okay. So I take this 54.1, I multiply across, AE will just be this times tangent 33, of course, if possible. Instead of using 54.121, you key in 30 over tangent 29 times tangent 33. Then you'll get the most perfect answer, okay, before rounding off. Okay, so AE is about 35.147 meters. Okay, usually we use 5SF in between. Then to find the height of the tower will just be AE plus your EB. Okay, so you know this and you want to add to this, okay, which is 30. So simply you just need to add 35.147 plus 30, you get 65.147. Answer, okay, round off 65.1. Okay, 3SF. Okay, not last question. Question 13. Okay, question 13, let's take a look over here. I have a rectangular signboard, okay, of a length 120, okay, 120 cm, so EF is 120. They hung over a metal pole CAB, okay, using two wires AE and BF as shown. Okay, tell you that CD, okay, is a vertical wall, so this is a vertical wall, okay, means this is right angle. And DH, okay, is the horizontal ground, so here forms a right angle. Then the length of the shorter wire is 90, so this is 90. And here the angle ACD, this is 115. So they ask you to find the length of the longer wire BF, okay, so that EF is horizontal. So in this case, this is a very similar scenario or setup, okay. So I need to create my own triangle, which in this case will be using from A all the way across to here, okay. So this will be 90, this will also be 90, so all I need to find is just the shorter side over here. So let's see whether they got drawn in diagram. Yes, they did. Okay, so they use this as X. Let's call this X. So AE and XF will both be 90. They'll be the same. Okay, so AX will also be the same as EF. They'll be 120. So I know 120. Okay, I just need to find BX. Okay, so in this case, I can make use of tangent. Okay, so of course, I need to first find the angle first lah. Okay, because over here is your adjacent and your opposite. So to find the angle here, I know this is 115. Okay, using corresponding angles. Okay, this will be parallel to this, meaning CD will be parallel to AE. So this is 115, here also be 115. You minus away the 90 degrees here. Okay, then you can find this angle, which is to be 25 degrees. Okay, so let's look at the explanation. Construct a line AX, okay, such that it's parallel to the ground. So it will be right angle over there. So over here, they first find what is ABF. So ABF is this angle here. They say that this is 180 minus 115 to find this. Okay. In this case, it shouldn't be corresponding angle. This will be interior angles. DC parallel to FB. Okay, this should be interior angles, not corresponding angles. So 180 minus 115, you should get this. Okay, that will give you, I think, 65 degrees. So just now I was saying finding angle BAX, which is over here. But over here, seems like the solution find angle ABX. Okay, both ways will give you the same answer. Okay. So they make use of tangent, like I said. So if you know this angle on top is 65, you are trying to find AX. No, AX is 120. You are trying to find BX. So tangent angle. Okay, tangent is tua ka. So tua is opposite over adjacent. So it will be 120, which is your AX over BX, which is your adjacent. So AX over BX, so 120 over BX. Okay, substitute in, so BX will just be 120 over tangent 65 degrees. Okay, so once you have that, key into your calculator, BX is 55.96. Usually you do 5SF instead of 4. Okay, but once you have this, all you need to do, okay, you know that this, you know that XF is 90. So let's take 90 plus this. Okay, then you can get BF. Okay, so BF is just that plus 90. 3SF 146 cm. Okay, otherwise that is more or less it for this portion, okay, of the homework. So basically the questions are all looking at, I give you one angle, one side, you help me find the other side. Okay, so key thing is you need to know which is the trigo ratio to use, sine, cosine, or tangent. This depends on which are the two sides involved, okay, with the respective correct angle. Okay, so once you know one angle, you know one side, you can find the other side. Okay, that's all. Okay, if not, thank you. Bye-bye.